Welcome. Today we're going to be talking about a game-changing way of writing automated acceptance tests in JavaScript.
Cool. Hello guys, so my name is Jan Molak and you probably already know John Smart. We're working together mostly in the BDD and test automation space. So what we would like to talk to you about today is what we believe is to be the next generation of acceptance testing in JavaScript and TypeScript as well. And what we think should work really well with all the modern applications, especially Angular ones and any other stuff that you can test with Protractor.
So what we're really trying to achieve here is to bring to the table some of the advances we've seen in other areas of automated acceptance criteria to the JavaScript world, because we've found that in the JavaScript world it seems to be lagging a little bit behind in a lot of these areas. And we've been wanting to bring basically the power of what we can do with techniques like behavior-driven development, with requirements discovery, with sustainable test automation practices, and bring that to the world of JavaScript so that you can have the advantages, basically have your cake and eat it, have the advantages of these really sustainable, efficient, automated testing practices, not only in the world of Java, but also with your front-end applications.
Precisely. Now, before we go into the details, let me just ask you a question. Do you know what's the root cause of most issues with software? Any guesses? Users, all right.
Be much easier without these damned users, wouldn't it?
So it turns out that one of the major issues is, well, it is people, yeah, that's right. But one of the major issues are the requirements. So how big of an issue that is, you think? Can I just have a show of hands? How many of you think that, let's say, 10% of all software defects are caused by requirements? Let's say 10%, maybe more. Okay, 20? 50? 75? 100? Okay, so according to research that's been done over the last 30 years or so, between 44 and 80% of all software defects are due to ambiguous, unclear, or just simply incorrect requirements. And funnily enough, those problems have been around since 1985, that's when I found the first study, through 1995, 2005, and until recent days as well. So despite the changes in technology, the main issue is still the same. So it might make sense that as part of our test automation effort, we should perhaps address the root cause of all the problems.
And so that's where behavior-driven development comes into play. Behavior-driven development is basically an approach that brings together requirements discovery and a tight feedback cycle that you get from test automation if it's done well. Behavior-driven development is really about a conversation. It's about conversations you have with your business, with your product owners, and with your developers and your testers to try and build software that actually matters. It builds features that make a difference. And that's what we're trying to achieve in a nutshell when we do techniques like behavior-driven development.
Have any of you used BDD in practice on your projects? Okay, cool. So we've got some of you. Excellent. And how about domain-driven design? All right, excellent.
Yeah.
Cool. And what about the user-centered design? Okay, some of us, well, not as many. So what we'll look into today is how we can bring together the techniques of behavior-driven development, of domain-driven design, and user-centered design to give us this next generation of acceptance tests.
what we find one of the biggest problems with acceptance tests, or with automated tests in general, when we go to client sites and we see how they do them, is they're flaky as hell. It's very hard to get them to scale reliably. And this creates a whole chain of problems because we end up with tests that basically people don't believe, you don't trust them, the business doesn't trust them. If the business doesn't trust them, then we can't use them as part of the build cycle. They don't give the feedback we need. There's extra time that people need to spend debugging them or triaging them. And so this leads to a whole chain of problems and basically defeats the purpose of any approach, any movement going towards lean or DevOps. So what we really need to do is try to make our tests, what we identified here are three main attributes. So we want our tests to be reliable. So if it passes, it passes. If it fails, it fails. It sounds obvious, but a lot of tests become flaky very quickly when we get into the acceptance test level. We want them to be scalable, and I don't mean scalable just that you can run 1,000 tests in a reasonable amount of time. We want them scalable in the sense that if you bring on 10 new developers or 10 new test automation specialists, you want them to be able to come on board and be productive very quickly. You don't want to have a Byzantine monolithic test framework that nobody could understand, and when you change something over here, it breaks something over here, which is often what we see. And we also need them to be actionable. We need them to be presented in a way that you can actually do something about so that you can see the results and figure out basically what's the purpose of your test? Well, it's to see whether your application is release ready. So a list of test results doesn't really give you that. You might have 100 tests that are green, but if they don't test the right features, not a lot of use. So we want tests that actually demonstrate the features that you're trying to deliver and how those features are tested. If we can get to that point, then it starts to get interesting.
Mm-hmm. And because BDD is all about having conversations around concrete examples, we would like to give you a concrete example right now. So, okay, how many of you have heard of Cucumber or maybe used it on a project?
Quite a few.
Excellent, lovely. And how many of you think that it's a very good test automation tool? Okay.
Not too many, very good.
Not too many. Interesting. So Cucumber is one of those tools that's greatly misunderstood. So even Aslak said, and I'll quote him here, Cucumber is first and foremost a collaboration tool rather than the test automation tool. And please keep this in mind while we go through the example. So here's our feature that, let's say, we discovered as part of our BDD process, as part of our 3 amigos. So I'm sure you're probably all familiar with to-do lists, reminders, all this sort of stuff. So that's an example of such application. So we have a feature that we would like to filter the list to find only items of interest. And as part of our UX process, we've identified a persona of James. So we would like to enable this particular feature for James. So far, so good. Now, let's say we've got a number of scenarios of how this specific feature could be used. So in here, we've got James starting with a list of 2 things. He completes one of them, then he selects a specific filter, and he only sees the item that he hasn't completed yet. So at this level, it's all very high level, very business specific. We've got no reference to low-level implementation, nothing about clicking buttons, entering values into fields, nothing like that. So far, so good. So we've got scenarios. Now, the next step that we would need to take is to automate them. And that's where some things might start to fall apart. So from communication to automation. So let's see how we can automate the scenario we just looked at. So first of all, if we are using Cucumber.js, we need to create so-called step definitions. I'm guessing probably some of you have seen those before.
Hands up if you've done this sort of code with Cucumber and JavaScript. Anyone?
Or Java or Ruby. I mean, it's all similar concepts.
Yeah.
Cool. It is a Java conference. Cool. So the first idea that we might have about automation is that we could try to implement our tests like that. So what we do is we jump straight from Cucumber, from this high-level definition of business goals, business objective, personas, and all the business lingo, straight to Protractor API, or in Java world, the WebDriver API. So a very low-level driver that interacts with the browser. And here's where so many problems actually start to crop up. So first of all, how easily can you tell what this code is doing? It's quite a lot of things happening here, right? So we're navigating to a specific page, we're doing some data transformation, or maybe we need to split a list, we need to transform it, do some stuff, and at some point we actually interact with one specific element of the website. Now, the problem here is that Cucumber step definitions are not really designed to be shared or reused, right? Cucumber is basically a parser of scenario files that then executes the code of your test framework. So if we just try to directly invoke Protractor, we might end up with code like this. So code that's not really readable or reliable or easy to maintain, easy to change, and so on. Another problem is that now, if we make this jump straight from Cucumber to Protractor, we lose all the business context. We jump straight from the business domain to our implementation domain. So try to give this sort of code to any of the business stakeholders on a project to read and verify. It's pretty much impossible. Also, if a test like this fails, we'll only have the granularity of our report pointing us at a specific step in a Cucumber scenario, not a specific task that the user was performing. So that's probably not what we want to do. So there is another popular approach in the JavaScript and Protractor world, is to structure those tests a little bit better. So instead of just writing the script, we could try to come up with some page objects. And have any of you used page objects on your projects?
Quite a few, yeah.
All right.
That's a step in the right direction.
Mm-hmm, definitely. And quick question, actually. How long do you think a page object class should be? How many lines should it have? Let's say 50? Is 50 okay? Just raise your hands if you think that 50 is fine. Okay. 100? Is 100 still okay? Okay. 500? We've seen some that were actually 1,000 lines or longer. So we'll get to that in a moment. So what you see here is now, instead of just calling the APIs directly, we created some page objects and we're calling those instead. However, this didn't really help us that much, because now we still have a lot of noise and still of data transformation here. And we really still have the same problem. And if we look at our page object definition, well, we've introduced some concepts of the domain vocabulary here. So we've got things like adding items to a list, or maybe completing an item, or removing an item, and so on. And those all work fine. The trouble is that the richer your domain is, and the more complex your application, the longer those page objects get. And this, of course, affects the reusability of code and maintainability and how easy it is to share. Because now at the point in time where those page objects reach 500 or 1,000 lines of code, they're just big blobs of stuff. And it's quite difficult to figure out what is the responsibility. And obviously it's no longer single. It's another problem with this one is that in JavaScript, you also have to synchronize any operation within Cucumber steps with the Cucumber driver. So Protractor, same as the WebDriver.js library, they use their own implementation of promises. So that's what's called the control flow. So they're not standard Node.js promises. They will be just scheduled, put on a queue, and executed at some later point. What this means is that Cucumber is not aware of this promise chain. So if you have 10 steps in Cucumber, and you've got your failure in the third one, it will just happily go through all the steps and tell you that all the steps have passed, and you've got a failure in the last one. So that's problematic, especially when you try to figure out where the issue is. Okay, so can we do better? And that's actually the core of what we wanted to talk to you about today, a screenplay pattern. Have you guys heard about it at all? Okay.
Few people.
Nice.
Good.
Any good things? Okay, so let's take a step back. So if we try to think about our acceptance tests, not from a perspective of a browser that interacts with a page, but from a perspective of a user that is trying to accomplish some tasks or some goals in our systems, then we could use a technique that's called hierarchical task analysis in user-centered design. So what it's all about? So with this approach, we start with an actor. So either a person or an external system that interacts with our application. Those actors have some goals they try to accomplish. It could be to make a purchase of a product or to register an account or whatever our business goal is. In order to accomplish those goals, the actor needs to perform a number of tasks. Those tasks are then composed of interactions with the system. So if we have a look at the feature definition as we had it before, we could try to go through this process of task analysis and try to slice our scenario definition in a slightly different way. So it's still the same feature file, still the same scenario. But now let's try to identify the actor. So it turns out that if we have a UX process in place, we might actually already have some personas. So that's cool. So we could use those in our tests as well. If we're using Cucumber, well, we already have the goals. Well, the goal is the title of a scenario. So that's what the actor is trying to accomplish in a specific case. Now, where do we get the tasks from? If we keep our given whens and thens at a reasonably high level and focus on business objectives, then those tasks, those steps from the Cucumber file could be actually mapped pretty much one-to-one to tasks of the user. So in this case, we've got James who wants to see active items only, and he attempts to start with in a specific state of a system, perform some tasks, so complete an item, filter a list, and then he expects to see something. Now, if we take this idea further, we could actually see that some of those tasks can be composed of other lower level ones. So, for example, to start with a list containing some items means to open the browser, resize it, add it to the item, and so on. And we could continue with this process until we have a fairly rich vocabulary of all the activities that a user or an external system can perform within our application. And then at some point, those tasks will need to interact with the system. So there will be a layer of low-level interactions. So at this stage, we only say that we enter a value into a field or we click a button and so on. Now, it would be pretty cool to be able to express that in code as well, right? So that's what Serenity-JS allows you to do. It allows you to build this rich vocabulary based on some interfaces, code templates, and so on, and design your tests in a similar way as you would design a workflow from a user experience perspective.
So the impact of these tasks, these actions, these interaction objects, using objects instead of functions, using the way we've structured it there, and what we'll see shortly in the code, it is really a game changer when it comes to making your test suites maintainable, making them easy to scale in the sense of bringing people on board. It's much easier to get people up and running very quickly, much easier to come back and maintain the tests, and there are a lot of nice characteristics in the reusability of these tasks, these objects, where once you do one, it's good. You don't need to touch it anymore. So the maintenance goes down drastically. You don't ever need to change a task once it's completed, unless the application underneath changes. Makes it much, much easier to maintain the code base. And we've seen this in practice. You can come and ask us after the talk, but we've seen this in practice many times, and it is really very spectacular.
So let's have a quick look at the parts that make up the screenplay pattern. So first, we need to define what the actor is. So it's very straightforward. We just introduce a new variable. Let's call our actor James. That's an actor named James. Now, the next part of the screenplay pattern is the abilities. So in this case, James is a persona who's capable of using a web browser. And he could be using other means of communicating with our application as well. He could be using a REST client or an FTP client or pretty much any interface to the system that we have.
One minor detail here, we are actually using TypeScript rather than JavaScript. So anyone familiar with TypeScript? So if you're not familiar with TypeScript, there's a talk on it by someone who we mentioned earlier on.
Yes, Dominic, I believe.
Dominic,
yeah, Dominic
yes.
Kundel. Mm-hmm.
Yes, there's a talk tomorrow afternoon on TypeScript if you want to learn more about that.
Mm-hmm. So an actor can perform tasks. So in the case of the Serenity-JS implementation, what we do is we basically invoke the attempts to method on the actor, and we give it a number of task objects. They're just basically commands that you can chain together. And if you wanted to plug them into the Cucumber steps, well, the only thing that we need to invoke there is this code, James attempts to start or perform some other action. So it's pretty much a one-liner. So we don't really have any additional code in our Cucumber step definitions. That's where we're using this one-to-one mapping characteristic of this code. And because the tasks and interactions are just classes, those can be reused much easier than Cucumber step definitions. Now, another property of those tasks is that they can be composed of some lower level ones. So as you've seen before, to start means to open a browser, resize the browser window, and add some items. Now, what does it mean to add an item? It means to enter a value. It means to hit the enter key. So it's all pretty straightforward, right? I mean, we're able to explain how the pattern works to you in about, 10 minutes or so? So what we've noticed is that this is a very powerful concept, and it's very easy to grasp no matter how experienced the developers are. Because if the developer is experienced, they can grasp it in a couple of minutes. If less, well, maybe half an hour or so. But it's still very easy to understand. Now, another property of a task is that it can be annotated. So that's a feature that comes with TypeScript, is that some methods can have annotations. And the way we use them is we use them to map a task class to a piece of text that will be then used to generate a report of our test execution. And those reports are what you can very easily present back to business stakeholders. So what they can do is they can go through HTML, click on every single one of the tasks, figure out what it means to perform a specific action, find an attached screenshot that shows the state of the application at which it was when the task was performed. So it's quite a powerful media to explain to all parties in your organization how your tests work, what is the value of those tests. And we'll show you those in a demo in just a second. Literally, just a second. I think I need to do some magic. So all the code that I'll be showing to you now is available on GitHub. Serenity.js is a free and open source library that you can clone right now and play with the example yourself. Okay, so let's start at the feature file level. So as you can see here, I've got an example project in which I have some feature definitions, some source code for the project, and so on. At the feature level, I've grouped the feature files into directories. And those directories correspond to high-level capabilities of the system. And those will become important when we analyze failures of tests in order to find out what the severity of the failure is. So let's start with the feature file. As you can see, we can just go through each of the steps, see the invocation of a task, see the task definition, the annotations, and so on. The same thing as was in our presentation. But let's try to run the tests now. So I'm executing them using just the regular npm runner. So that probably looks familiar. Oh, okay, it's still here. So as you can see, under the hood, it's still executing the regular Protractor interactions with the application. With this minor difference, that after a test run, we can have a much more in-depth report. And I'll hand over to you, John.
So essentially what these reports are about they're not just test reports. There is a list of test outcomes. You have the tests that were executed and whether they passed or failed, but that's boring. What's really interesting is the fact that what we're really reasoning about is not just test outcomes, but capabilities and features that we're trying to demonstrate. So the point of a test is to demonstrate that a feature is ready to go into production. You have a number of tests which collectively can build confidence in whether your features are ready to go to production. And that's what we're doing here. So we've got the find things to do capability, and that is made up of one feature, filter the list. So in a bigger application, you probably have more. And then inside that particular feature, we have what we saw in the Cucumber file in order to limit cognitive load and so forth. And we have a number of acceptance criteria for that feature which map to your acceptance tests. And then if we want to drill down into those, we could drill down into any one of these. And these are the tests that we saw being executed earlier. We can see the description of what the feature is, and then underneath we get a high-level overview of how the feature was demonstrated. And if you're not satisfied of what that means, and he writes some code, then you can open it up and see what that actually means. So James Marks writes some code as completed, and how did that work? Well, he clicked on the checkbox. Go down as far as you need to illustrate exactly what you're trying to do, or keep it at the top level if you just want a summarized version. And naturally, you have screenshots to illustrate each step. So what we have here is what we call living documentation at a top level, viewing from what capabilities and features are ready to go into production, and from a detailed level, how does each feature work?
So it's all nice and well when the tests pass, right? So let me just break them for you quickly so we see how this is reported as well. Okay, we've got a scenario here, write some code, and I think I probably need to get a coffee as well. And PM run clean, so I'm just removing the test results from the previous run, and PM test. So what I just did is I introduced a change in one of the feature files which will cause the test to fail, and I should be able to show you how the failure reporting looks. Because what you might have noticed on the previous screen where the report was shown is that we didn't show any XPath selectors or CSS selectors or any of this noise. Because if all the tests are working fine, then there's really no reason to pollute the report with this sort of low-level implementation detail. However, if the tests fail, we'll actually give you all the details so that you are able to find where the problem is.
So now we can see we've got a big slab of red, but it gets more interesting because if we go into the actual failure, we can see it was viewing completed items only which failed. Let's see what went wrong. we're expecting write some code, and that's been cut off, so we want to see a more detailed version. Expected write some code to equal write some code, get a coffee. So we get a business level description of what went wrong, which is, if you're trying to figure out as a tester what is actually broken, this gives you a very fast way of identifying what's going on. Then if you really need to see the details, you can have a look inside the test. But at this level, we're talking in business terms, not in terms of XPath or so forth.
And what this translates to in business terms is that if you have your business person looking at the test report, they can immediately see that, well, checkout is broken, or people can no longer pay for our products. And that's important, right? It's much more powerful than telling them, well, we've got 5 tests out of 500 failing, and there is some problem with a selector. People get bored when they see this sort of stuff.
So all of this code is available on this repository on GitHub, so please do check it out, clone it, and play around with it, and let us know what you think. And we will hang around a little bit for people who want to have questions. I think we have been out of time for some time now, so thank you for staying a few more minutes and listening to our full presentation.
Thanks so much for your time. If you'd like, we've got some Serenity.js stickers here as well, so
yes,
just come over, say hi.
Stickers, laptop stickers, they're very cool.